More black hole mergers? Welcome to Rubles Rambles here at the Makeums. So, this week, LIGO, which I talked about last, February, not this past February, has detected another merger of two black holes. This is the third one, and it's on its way to having gravitational wave astronomy be a whole new field rather than just like a few fluke things. So what happened is two black holes, one of around 31 solar masses and one of around 19 solar masses, were orbiting around each other, and then as two massive bodies accelerate, as orbiting black holes do, they emit, well, as anything accelerates, it emits gravitational waves, but they're pretty much non-existent for small stuff, like when you throw a baseball. They are there, but they're insanely small. But stuff many times the mass of the sun accelerating really quickly around each other, they can produce some more serious black hole gravitational waves. And then it takes energy to produce gravitational waves, so that makes their orbit decay, and so they spiral in closer and closer and closer. And then when they merged into one black hole with a mass of around 48 solar masses. So you may notice that there are around 2 solar masses missing. That mass was converted into energy, and a big pulse of gravitational waves radiated out, and us 3.5 billion light years away have just detected it. So this happened 3.5 billion years ago. So LIGO, there are two of them, one in Louisiana and one in Washington. They have 2 arms, and they work by bouncing lasers down each of the arms at the same time, and they use interferometry, where the light from each laser will interfere with the light from the other laser in a certain way, and they can very precisely measure the length of each of the arms. And when a gravitational wave goes by, it stretches space-time and makes one of the arms a little bit longer than the other one. In this instance, it was less than the width of a proton. That's how precise these things have to be. And that's why they have one in Washington and one in Louisiana, so that like a truck going by won't cause a fake detection, because they're far enough away that if there was an earthquake or something big enough to cause something in both detectors, we would know about it and be able to know it's not gravitational waves. So you may have thought, hang on, E equals mc squared, which means for a tiny bit of mass, like if you set m to like 0.00001, c squared, the speed of light squared, is a giant number, so that's a ton of energy for a tiny bit of mass. So when you've got quadrillions of tons of mass, 2 solar masses converted into energy, that energy is on the order of 10 to the 48 joules, which is just completely insane. That's more than the sun will emit in its entire lifetime, emitted in just one instant from these 2 black holes. And that's why we can detect it 3.5 billion light years later in a galaxy far, far away, which is where we are. So this is also yet another confirmation of Einstein's theory of relativity, his general theory of relativity. The previous gravitational wave detections were also confirmations. And this is, the gravitational wave detections, this one and the previous 2, are the only direct detections of black holes that we've had so far. We've got lots of indirect detections, but these are the first direct detections. So yeah, this stuff is just mind-boggling. If you have any questions about it, feel free to ask me. Don't forget to look for the International Space Station. Hopefully it'll be clearer now than it was after the last week's ramble, and clear skies.